Hello there. Today, me and my group are going to be speaking about reverse engineering the brain. So, as we all know, this is one of the grand challenges that the world is facing right now. There's many scientists and engineers from different majors who are trying to figure out the best way to translate the human intelligence into a computer readable format to use it for the advancement of technology. So as we know, reverse engineering the brain is basically studying how the brain works in order to build some type of artificial intelligence or artificial brain so that it can later be used in the advancement of technology. Now, efforts are being made by the different scientists and engineers to see how they translate this intelligence that human brains have into a computer readable format.
This challenge was born out of the need for both a more personalized medicine and building smarter computers. Understanding how the brain works could help doctors to have a deeper understanding of the body and also to identify the specific factors that determine sickness and wellness in any individual. In order to build smarter computers, the NAE has reconsidered the way artificial intelligence has been developed from the beginning. Now, instead of trying to create a computer's brain from zero, they encourage engineers to try to simulate the human brain and its millions of processes. Deciphering how it can develop multiple tasks at the same time is the midpoint of reverse engineering the brain. One day, hopefully, the human brain, used as a guide, will lead into the most efficient engineering of artificial intelligence.
When it comes to reverse engineering the brain, there are many challenges that engineers and scientists alike face. In order to overcome such obstacles, we first have to identify what they are and brainstorm potential solutions. Some obstacles that come with this challenge are due to the fact that the way that the brain communicates has a secret code that has yet to be deciphered. The rate that nerve cells fire depends on the sum of incoming messages. The brain fires a plethora of neurons at rapid speeds, and there are millions of nerve cell pathways that fire at different speeds and during different activities. Each nerve cell receives messages from tens of thousands of other cells, and circuits of nerve cells link up in complex networks, making it extremely difficult to completely trace the signaling pathways. Due to these complex nerve cell signals, their dynamics, pathways, and feedback loops, there is no supercomputer currently available that can compete with the human brain in either computational capacity or memory storage.
So whilst it's difficult to choose solutions, one way to go about these issues is to first and foremost focus efforts on advancing the supercomputers, because at this stage in the game, knowing how the brain works and the processes and what it does would be pointless without a means to execute and replicate said interactions. So by focusing efforts on the computer itself, then engineers would be one step closer to being able to follow through with their findings. Another solution would be to focus on one neuron pathway at a time of basic human tasks, because there are a plethora of complex neural pathways that are constantly evolving, but if we focus on the typical human behaviors and the neuron pathways associated with those, engineers can gain a deeper understanding of what neurons like to fire during what sorts of activities and when they like to fire, which gives a solid ground to then later tackle bigger medical issues such as paralysis or dementia, etc.